Hey everyone, it's Anna Ruth from 61B, and today we're going to be talking about the Spring 2020 final exam, specifically question 8 that has to do with sorting. Okay, so we have an input list given to us, and we are trying to determine what sorting algorithm is being used that might create some of these intermediate steps. Over here at the top, I've also linked this worksheet that I'm working through in the description that has all of these notes written on it. But the idea is that we want to create some sort of heuristics so we don't actually have to perform all of the sorts and then compare all of the different intermediate steps, right? That would take a really long time. And our goal is to just look at a series and be like, well, based on a series of logical guesses and deductions, right? Based on the specific orderings and swaps that are being made, what exactly are we doing here? Right? What algorithm is being used? So for insertion, right, we can think of it as like we have some parts that are being sorted, and then we keep adding things to that sorted thing, right? And it keeps growing in size. Selection is that we just keep taking the smallest item and then we put it at the front. Heap is actually kind of the opposite, right? We have the largest items in the back, right? Because we're keeping that max heap-like structure. Merge, we're going to go ahead and watch out for that combining procedure, right? It depends exactly how it's being implemented, right? So in this particular worksheet, we are allowing merge to be like to be separate, right? So we're not doing it, we're sort of treating intermediate steps not as like both halves working conjointly. So that's why I've written it like this. If you are in Spring 2022 and you've done the exam prep 12 worksheet, you look at the solutions, right? You'll see that in merge that we talk about how the two halves don't interact. Well, in this particular version of the exam, we don't have that assumption going in. And then we have a quicksort where we're going to use the pivot, right? So we notice that once I have a pivot in quicksort selected, that pivot stays the same throughout. And then LSD and MSD, we're going to go ahead and use the patterns in digits. Also, as a quick note about what I was saying with merge, just note that, or actually in all of these, note that these are all just general guidelines that we approach, right? So these are not necessarily definitions of how the sorts work, but these are things that will help us identify what the sort is. And then when we come back again, or if we're unsure, if we want to check our work, then we can go into more detail on exactly what we're doing with the sorts. Okay, so check out this first one, A. So we're given the same input list, right? Again, and then we're given that where 43 comes to the front, right? So immediately maybe there could be selection, right? And then we're selecting again. But the problem is that we're also just seeing a bunch of these other numbers, right? In selection sort, you're only really making one swap, right? You're just bringing whatever you need to the front. Well, you're just seeing so many other numbers here that doesn't make sense anymore. With merge sort, right, we're not really seeing that combination procedure. Like this almost basically looks sorted. And when you realize that it basically almost looks sorted, that's actually a very key indication that it might have to do with the patterns of the digits, right? Like why do the human eye does it seem sorted? Well, it's because a lot of the hundreds places, right, in this line right here are actually sorted. And in fact, that's how we do MSD, which is what this question is doing, right? We sort first by the hundreds, then the tenths, then the ones places, right? And that's exactly what we're doing here, step by step. Okay, and again, the way to notice that is just by looking at the patterns of the digits. Now for part B, we are doing, again, another sort. This time, what we're trying to do is figure out what exactly causes the change from this first line to the second line, right? So we're not moving 43 to the front, but now we're moving 43 over to the middle, which is interesting. Okay, why exactly are we moving 43 over to the middle? Well, that's a good question to ask, right? Because now we have to think about which sort would cause that to happen, right? Insertion sort wouldn't cause that to happen because insertion sort, you're expanding these subparts, right? The second you include 43, 43 is going to the front. That's where it belongs, right? In insertion sort. Selection sort would have put it already at the beginning. We're not seeing evidence of the combination process anywhere here in merge sort, right? We're just throwing things around. It's 43 over to the left. We're not really seeing, we're not really seeing evidence of any heap sort, right? And you can notice from the fact that I skipped over quick that it is quick sort. And then again, if you look at LSD and MSD, for a lot of these actually, if I'll mention LSD or MSD, you can skip by just looking at the numbers and seeing violations that would not be allowed under LSD or MSD, right? For example, if I have 4, then 3, then 2, then 6, it doesn't matter if it's LSD or an MSD, you can't have it decrease and then increase in its very first iteration by the hundredths or the ones place, right? One of them has to hold for it to be LSD or MSD. So with all this in mind, right, we know that it's going to be quicksort, right? But the problem is exactly how do we know that? Well, we can verify that very quickly by going ahead and taking the middle the last, and the first elements, because we're told the procedure for selecting the pivot is the median value of the first, last, and middle elements. So the median value is 592. And in fact, we notice 592 remains fixed. And all we're doing is taking the elements that are smaller than 592, putting it on the left of 592, taking the elements that are bigger than 592, putting it on the right of 592. And it's exactly the quicksort procedure. And if you want to repeat the process over and over, you can go through the rest of it. We can also start to see some patterns, right? So we notice that 615, 674, 759, 834, in fact, all of these, right? But nothing really over here on the left. The 62, yes, but other than that, we aren't quite seeing anything, right? That is actually 193 as well. Other than that, we aren't quite seeing anything, right? Because they're all changing, like 191 at the last moment over here, right? 43, 265, these are all changing at the last minute. So we know that those are not going to be our pivots, right? So at this point, we've done enough work to confidently know that it is going to be quicksort, right? Especially because we know that it cannot be any of the others. But if you were coming back on an exam where you had more time, this would be a good chance for you to then go ahead and derive each of the pivots of each of the smaller subsections. Okay, let's go ahead and move on to C. So now for C, what's something interesting that we can note? Well, the 62 comes to the front, right? Which kind of rules out selection sort. Insertion sort, well, by the time the 62 comes to the front in insertion sort, this list will have been sorted, right? Because if you keep expanding, if you expand to the list to be the whole size, then the whole thing has to be sorted. Merge doesn't really make sense because if we have 62 to the front, well, the only way that I'm going to have the right half come all the way over to the front, right, would be if the whole thing is sorted. But that would never happen in merge sort because 43 would be the one at the front. Quick sort doesn't really make sense because, well, this 592 would not change its position. It turns out heap sort, right? Heap sort kind of makes sense. Heap sort might not make sense at first, right? Because we have the 62 in the front, and you might say to yourself, well, shouldn't you have the max value at the front, right? Like, shouldn't you have, let's say, for example, you have 920 at the front, then you pop up 920 out to the back. Well, it could be the case that we're in the middle of the heapification, right? Remember that if I have a heap structure and I'm popping the minimum off, I take this smallest element, right? This complete. I suppose I'm not sure on your screen if this is showing the bottom right element, but from my hand, it's my right hand. So I take this, I put it up here, I remove the min, right? And then I go ahead and throw it at the end of the list, right? So that's sort of how I'm thinking about that. And when you think about it like that, okay, well, that kind of makes sense. Well, what's really interesting is I can actually draw this to reinforce my point, right? Which is that we're sort of treating this as the already sorted, right? Sort of like the opposite of selection sort, where we're taking the smallest element to the front and just treating like it's already sorted. We're not going to touch it anymore. Well, now we're just doing the same, except, well, now we're taking the biggest elements and we're using the max heap to sort of keep track of our elements instead. So with that in mind, we know that this is going to be heap. Okay. Now let's go on to D. So with D, this one, let's start out with, could it be insertion sort? Well, if it was insertion sort, we'd have 674, 193, we'd sort those, right? So perhaps that is the case, right? We know that it would not be 523 as well because it's not incorporated. Then we have 193, 42, 523, these are all sorted, and we know that it cannot be beyond that, right? So it could be stopping here, it could be stopping here, right? But actually, wait, no, it could not be stopping there, right? Drew one too many, right? And the reason why is that by the time we add 482, we're adding into an already sorted list, right? So every single time we take an element and we add it in and we adjust that element's position, we know that that whole thing has been sorted, right? So that has to be true. And if you can tell where I'm going with this, this does turn out to be insertion sort, and we can keep expanding this, right? So then in the next line, all we're doing is we're adding in the 834 to the right location, so on and so forth, right? And so insertion sort is one of those things where it's actually very nice to be able to sort of look at it, right? Because the rest of everything else looks unchanged, so you're able to sort of zoom in on that. And for very similar reasons as the other ones, right? We notice that the MSD, LSD patterns are being violated. The heap thing doesn't really make sense, right? Because I can't isolate that the largest values are being selected at the back and they're not being moved. Quicksort doesn't really quite make sense either, right? Because we're not actually using 592 as a pivot anywhere here. And then we're not doing the combination process of merge, nor are we taking the smallest element and putting it at the front immediately as we would with the selection sort. Okay, let's go to E. So now for E, well, I guess I have a mark already under 920, but the idea is, why is 920 coming to the front? Well, this led me, right, to think about, is there a pattern in the digits, right, that leads it? Because if you think about it, insertion sort doesn't really quite make sense for why 920 would come to the front, because by the time 920 comes to the front, well, this whole section has to be sorted, but you've already included 191, but then that doesn't really make sense for 191 to be sorted. In fact, it doesn't really even make sense for 920 to be at the front at all, right? 920 should always be at least here or back because it's the largest element. So the fact that it's at the front, right, is already kind of throwing things off, because it means insertion sort can't work, selection sort can't work, merge sort, well, why would merge sort ever put it at the front, right? That doesn't really make sense, right? Because merge sort is going to do comparison-based sorting. It's always going to try to push it as far back as possible. Again, quick sort wouldn't work, right? Because regardless of whatever pivot you choose, it's always going to go to the right. Even if you choose 920 as the pivot, even if you choose the smallest element as the pivot, it'll always shift toward the right. And then heap sort, well, in heap sort, we do something very similar to what we did in part C, right? And you can see where I'm going with this. I guess it's like, even if you don't immediately see this pattern of, oh, it's the 0 that's leading to 920 in the front, the process of elimination, right? MSD doesn't make sense because the 9 in 920 can't be the reason why it's in the front. So it has to be LSD. But then if you take a closer look, right, the same way how we did with MSD, in LSD, it's one of those things where you can almost always quickly and accurately confirm your intuition, right? All you're doing is you're checking the ones, the tens, and the hundreds place are all being sorted on. And if you go ahead and check that here, you'll see that's exactly the case. Okay, now let's finally talk about F. So F is a little tricky because if you notice on this whole section, nothing is being changed at all. And if you come over here and look at this left section, things are being changed, but things are being changed in a somewhat interesting way, right? So maybe at first you're thinking it's insertion sort, right? So it's like 193, 674, 193, 674, 482, 523. We notice no other changes. Then you see it's 193, 482, 523. We have the 920 incorporated, right? We've swapped in the 674, but wait, right? This could never exist in insertion sort, right? The idea is that even though it seems kind of ish like insertion sort, this would not ever happen, right? And the issue with this is that we cannot have just the exact same line happening again because we're swapping these two. But swapping those two does not allow us to maintain that insertion sort idea, right? So it means that insertion sort is ruled out, right? And I think in this particular question, the reason why I chose to do that, it was not because I wanted you to feel like thrown off, but rather it's really just to point out in these kinds of questions, it's so easy to just go with what you're thinking, right? You think it's insertion sort, you're going to try to make it fit insertion sort, right? So let's keep going. So selection sort, well, selection sort, we're not moving 43 to the front, right? Selection sort, we would move 43 to the front. We'd keep trying to put that smallest element at the front. Merge sort, well, maybe it's merge sort, right? So if I draw this, and then I have this, and then I think about this as two separate things, right? And then I'm merging them together. Well, this seems to be an instance of the combination stuff that I was talking about, right? Maybe I can think about this as like I'm having, sublists of size 2, and then I'm going ahead sorting each one of those sublists of size 2, right? I'm creating another sublist of size 1, right? And then I'm merging those together, and then I'm merging the sublist of size 2 together. Well, we can confirm this intuition. If that's the case, well, then these 4 should be a sorted version of what's right above it. And it turns out it is, and then this should be a totally sorted left-hand portion, which it is, right? So we know that it is going to be merge sort, right? Except what's going on here is that we're doing merge sort, just showing like different iterations, right? So it's like the left and the right halves never interact, right? Which is a given case. But we can actually go a step beyond that, and we can find that combination property, right? We can find the fact how we're combining things together, and that's what's really going to tell us that it's merge sort. And just for fun, we can go ahead and take a look at quicksort, right? That quicksort is not going to work almost immediately, right? Because we're going to go ahead, if I scroll up, remember that we chose 592 as our pivot. Well, 592, for one, is not in the correct spot, but also is being changed, right? So we know that is obviously not going to be the pivot that we're choosing. And a heap sort, well, 920 should somehow, some way go to the end, right, soon, right? Because even if we were to heap this up, we could draw it out and realize that that's not a valid heap and that we're making swaps that don't really make sense in that context. And of course, LSD, MSD, those conditions are being violated, so it doesn't really make sense to continue looking at either one of those. So I hope that this was helpful, right? It might seem like I was taking a lot of shortcuts, a lot of estimations, a lot of judgment calls that seem like I almost knew the answer. And the answer is, well, yeah, kind of, right? Because when you do enough of these questions, you start to notice these patterns yourself, right? And you start to think of it as like a checklist, right? You start to look and see, oh, well, is this insertion sort? Let me go ahead and check. Well, is it not insertion sort, or is it close? How close is it? And then as you start making those kinds of judgments, over time, you'll get better and better at doing it. So that's why I highly recommend that you do the exam prep 12 from spring 2022, because it's very, very similar in nature to these. I believe the exact same sort should be covered on it. So yeah, that wraps up question 8 of the spring 2020 final exam.